Hello, good evening and welcome. And it's Malika here from the National Space Centre. Thank you so much for joining us, especially on this evening. I know that there's a lot of people out and about enjoying this evening. So if you've joined us, that is very much appreciated, including our fantastic guests. So yes, we are joined by Libby Jackson from the UK Space Agency and, of course, the fabulous Sophie Allen from the National Space Academy. Good evening, ladies.
Good evening, Malika.
Good
Hello,
evening.
Sophie.
Hello,
Hi,
and how are
Libby.
you both? How are you at the moment? And you nice and busy?
Keeping busy. I've been working out what I'm going to occupy myself through this next challenging phase that we've all got. But work is certainly busy, and there's many things to do in the longer evenings. I've got a lot of knitting planned.
A lot of knitting, fantastic. And how about you, Sophie? How's the teaching? Because you're doing space engineering at the moment.
Yeah, the course and my students still keeping me on my toes and very busy. So I'm still doing some in-college delivery, some online delivery for that. Students are holding up really well in the current conditions. And I'm also yes, it's getting cold and dark, but that means we've got a chance to do some really good astronomy over the next few months. So looking forward to getting some hot chocolates on the go, sitting out in the garden and looking up to the night sky for a bit.
Yes, no, I nipped out last night and it was very cold but very clear. So the two go together hand in hand. And somebody did ask us actually just a moment ago about when's the best time to see the moon. So if you go out right now, actually it's looking really good. And of course we've got the Taurids meteor shower coming up the 9th to the 11th of this month. But you might be able to see a few early, smaller meteors passing. And I think Mars is up there as well. So lots to go out and have a look at in the night sky. Do check out our website. If you go and have a look at spacecentre.co.uk, click on news. There is a blog that how you can see the meteor shower. So that's something exciting to go and watch. But we've had hundreds of questions. We've had so many questions. There's questions coming in now, and I've had questions in advance. So instead of me waffling, let's get some experts to talk. So Libby, this is to you. So Keith via email would like to know all about the UK Space Agency and what does it do?
Well, some people haven't heard of the UK Space Agency and think that all space is done by NASA, because NASA is really exciting. NASA is the American Space Agency. The UK Space Agency is the UK Space Agency. Does what it says on the tin. So we are part of government. We set the strategy for civil space, so things that the UK do in telecommunications, things that underpin everything we all use every day, telecommunications, global navigation, satellite navigation, and a lot of the science that happens in space. So I look after human exploration in particular. So the strategy, the policy, the budgets. I really work with the scientists across the UK and industry who use the places like the International Space Station and a whole lot of other facilities that we've got on Earth to do experiments that inform us about everything here on Earth, how plants behave, how cells behave. We do science on the International Space Station that's looking for new drugs to help with diseases, help doctors treat things. All of this because on the International Space Station, we can take gravity out of the equation. Everything on the International Space Station is in orbit around the Earth, so we are in free fall around the Earth. And say everything's there floating, so you don't feel the effects of gravity. So there's lots that we do. We also work with our partners at the European Space Agency, which is a collection of 22 different countries across Europe. We come together and we work collaboratively in space, because space is a really expensive, big thing to get involved with, and you can do great things when you come together. And it is worth noting, as we are 3 months or so away now from the end of the transition period and the UK leaving the EU, that the European Space Agency is not an EU organisation. It's a separate intergovernmental organisation, and the UK is remaining a member of that. We're remaining working with our partners there, say in many great projects such as the International Space Station.
Brilliant. Thank you very much. Yes, that came up. We were speaking to the fantastic Tim Peake last week, and the question that kept coming up was, is he going to fly again, and how is the UK going to participate in human spaceflight, or just in space in general, with the Brexit approaching? So I think we've got that covered, but that is really good to hear, so thank you for that, Libby. Now, the reason that we're here tonight is that it is the 20th anniversary of the International Space Station, which is an amazing facility in space that is a collaborative project that you talked about. And Sophie, you have worked and put, thanks to the UK Space Agency, put the Astro Academy Principia together and worked with Tim to provide educational resources aboard the International Space Station. Would you like to just tell us a little bit about that?
Yeah, so we were incredibly fortunate around the time of Tim's Principia mission to the International Space Station. We were given the opportunity by the UK Space Agency, so thank you very much for that, Libby, to put together some kit to send up to the space station that Tim could use to do experiments around elements of secondary school physics. So, as Libby said, when you're in orbit around the Earth, you're in a situation called microgravity. You can take the gravity out of the equation, and as a result, you can see some physics effects in motion that you can't really see properly on the Earth. And so it was a phenomenal opportunity. We produced some fantastic resources for that are still in use for the moment. And we can certainly drop a link to that perhaps in the comments after this session.
Yeah, no, absolutely. I will put a link to Astro Academy Principia on this conversation. So if anybody wants to go and have a look at the educational resources that are available still and see Tim doing some fantastic stuff in space. It isn't just a space station where people live. That's an active educational and scientific facility. So thank you for that. And we'll get back to that one. Right, so we've got some more questions. Number 2 is from Pan on Instagram. This one's for you, Sophie. How big is the International Space Station, and can you explain it in relation to something on Earth?
Yes, definitely. So, I mean, the International Space Station is a phenomenal achievement. It's a huge orbital laboratory, and in terms of its full size, so if you include the habitation modules, the research modules, if you include the solar panels and these big radiator panels that it has, then it's about the size of a football pitch in terms of its entire size. In terms of the habitable modules, so the areas that are pressurized, that have got oxygen and that are livable for the astronaut, then you're looking at something about the size of a 5-bedroom house, which might not sound that much for 6 people living in for 6 months. But what you have to remember is in microgravity, you're not limited to one surface. So while here on Earth, if I want to, have a usable working surface, I'm pretty much tied down to what I can attach to the floor. In the International Space Station, every surface, roof, sides, floor, can be usable. And in fact, there's not really a floor or a roof. There is no up or down. So you can just use the entire surface area on the inside of the station for work.
Fantastic, thank you. And I'm just going to throw another question in that's just come in live. Lisa would like to know how many people can fit on the International Space Station. Libby, can you help us with that one at all?
Yeah, at the minute there are 3 people up there. Usually in the past we've had 6. We've had 3 Russian cosmonauts and then 3 combination of US astronauts, people from the European Space Agency, the Canadian Space Agency, from Japan, the international partners who make it up. We're soon, though, next year going to see the standard crew rise up to 7 people. With the advent of these new commercial crew vehicles you might have heard about, called the SpaceX Crew Dragon or the Boeing Starliner. We might talk about that a bit more. They're new vehicles that it will launch from America. We're going to be able to bring more people up, have more capacity, so we'll see the crew go to 7. The most that we've ever had on the space station, I'm thinking off the top of my head now, I think is 13, when there was a space shuttle visiting the 6 crew who were on orbit. And there was 13 people living and working in that space for about 2 weeks at a time. And where they all sleep, some of them have their own crew compartments, the people who are living there for a long time, and the space shuttle people hung out and slept on the space shuttle. So 13 has been the most, I think, on the space station at any one time.
Wow, that would be quite packed. I think it's quite claustrophobic as it is. I was certainly looking at when there's a Soyuz launch and looking at how they're compacting that little Soyuz capsule itself. I can't imagine 13 people on the International Space Station, although with a shuttle attached, that is quite a large space, I suppose. But yes, thank you for that one. Right, we've got Catherine on Facebook. So this is quite a long question. This one's for you, Libby. Is it feasible for crewed or uncrewed shuttles between the International Space Station and the Moon to be permanently based on the ISS for more frequent and easier access to explore the Moon? If so, would there be options for UK-based companies to be involved with building and maintaining these shuttles?
What a great question, and opens up all sorts of different things to talk about. We have a plan, and when I say we, I mean the space agencies around the world. So the UK Space Agency working with our partners in the European Space Agency, and then in turn working with NASA for a new tiny space station out near the Moon, which is going to be called the Lunar Gateway. Now, Sophie was talking about how the space station is the size of a 5-bedroom house. This Lunar Gateway is going to be a small bijou 1-bedroom studio flat kind of thing, tiny. We will have to get astronauts from Earth to the space station. And what you suggest, to have this sort of shuttle between one and the other, is possible, but it's not our plans. Our plans at the moment, there's a new spacecraft being built by NASA called the Orion spacecraft. The service module for that, the bit that's got all the electrics, the solar panels that sort of keep the crew alive, is being built by the European Space Agency. So we're really partners in this. And that Orion capsule will take astronauts to the Gateway, and that's going to launch directly from America, from the Kennedy Space Center, where the space shuttle used to launch from, and go direct to the Lunar Gateway. But you asked, could UK companies be involved in this and so on? And what we're seeing as we expand human presence in low Earth orbit, where the International Space Station is, and the Lunar Gateway, is we're seeing partnerships now between government agencies like ESA, like the UK Space Agency, and private companies who are providing services. When we look at the International Space Station, I mentioned Crew Dragon and Boeing. The astronauts who are going to travel on those are buying tickets. NASA are buying tickets, just like you or I would buy a ticket one day, hopefully again, to go on an aeroplane and travel somewhere. They're buying tickets from companies for trips to space. And we're going to see more of that private operation as we look at the Lunar Gateway. We might see private companies provide cargo there. We've got UK companies who are looking at providing communication services around the Moon. And so maybe one day, what you say, is this possible? Perhaps. It's not in the plans right now, but that's not to say it couldn't happen.
Fantastic, thank you. Yes, lots of collaboration, I see. Everybody keeps wondering about this commercialization of space, but the reality is that the money that is pumped into it is pushing us forward. It is supporting that infrastructure of growth. It is supporting science and development and pushing us forward as individuals and as together. I think collaboration is going to be the big thing going forward, which is why the ISS is such a positive thing. Thank you for that, Libby. Sophie, one for you. So I've got 2 people asking very similar questions. So Brooke on Instagram said, do you think we will ever live on another planet? And Philip H. Tin has just asked, will we ever set foot on Mars?
Okay, great questions, both of them. I certainly hope that the future of humanity is to live on other planets as well as the Earth. Certainly that's what humans do. We naturally, by our nature, want to go out and explore, and that does seem to be what the next logical step would be. In terms of setting foot on Mars, I absolutely, without a shadow of a doubt, believe that humans will be setting foot on Mars quite soon. All of the big space agencies are firming up plans for crewed missions to Mars, for journeys to either originally orbit Mars or eventually even land on Mars for a relatively short period of time initially, to do research and to find out more about the science on the surface. The reason why we would want to send humans there, other than the fact that it would be a really great thing to do to have humans on Mars, is that humans have got a lot more autonomy. We can choose what we want to investigate, what we want to do. With a Mars rover or a robot on the surface of Mars, everything has to be planned really far in ahead, and they move very, very slowly, and you're limited to just doing the experiments they're set up to do. You put humans on the surface of Mars and take scientists and engineers there, and you've got the opportunity to do a whole lot more science. And so we are going to have humans on Mars. The Chinese Space Agency, NASA, European Space Agency, we are looking at the potential for future Mars missions, and it's going to happen, I believe, in the next 10 years or so. As far as living on another planet, that depends on a few things. First of all, if you wanted to live permanently on another planet, you need to put the infrastructure in place to be able to do that. So you need to make sure that you're able to continuously provide enough water, provide enough oxygen, protect the habitation modules from things like cosmic rays and radiation from space. So for short missions, you can just send the resources out there. But if you wanted to have people living there full time, then you have to invest in making it sustainable. And that would be a long way off. The other issue with going to somewhere like Mars is if you were to live there full time for quite a long time, because it's got about a third of the surface gravity that the Earth does, over time your skeleton and your muscles would start to waste away in Martian gravity. And that would make it really quite difficult and painful for you to be able to adjust to being back on the Earth. So if the time comes where we do start sending humans to live permanently on other planets, it's likely that they would be like colonies, independent colonies that would have to, stay out there rather than necessarily easily be able to shift between them. Certainly until we're able to travel outside of our own solar system anyway.
Oh, Sophie, you've broken my heart now. I've always wanted to be a potato farmer on Mars, and now I'm just worried about what it'll do to my body.
You can do it for a year and a half at a time. Go out there, do the research, and get it. And for me, that would be better because then you're not having to leave your family behind forever, but you still get to experience the amazing experience that it would be of living on another planet. Now, I have to say, actually, Libby, what's your view on this? What do you think about long-term living on other planets?
I think there's an awful lot of technology we've got to work out first. You covered some of it there, the radiation issues. If you're going to leave the protection of the magnetic field that is here on Earth, we know the magnetic field, it protects us from the solar wind and the cosmic rays. How can you live and work in that? That's a technology problem that we've got to overcome. There's the communication issues. The light travel time between Earth and Mars can be 4 minutes when they're at their closest, as they are about now, 20 odd minutes when they're at their furthest. And that means any messages you try and send are going to take a long time because information can only travel at the speed of light. So there's lots there. But one of the biggest questions for me, I think we also have to think about before we get to humans going all the way to Mars permanently, is what would it do if there was life on Mars? And I don't mean human life on Mars, I mean other life on Mars. One of the reasons that at the minute we're really interested in Mars for scientific reasons is that fact that it's very similar to Earth. In the long time ago, in the sort of early parts of the solar system, they were very similar, and we've got sort of similar-ish sizes. Gravity is not so dissimilar. Sophie was talking there about a third of it. Perhaps life has evolved there, and if it has, or it did, is it still there now? We don't know. This is one of the reasons that the Rosalind Franklin rover that's been built here in the UK, European Space Agency's Mars rover, is going to go and look for signs of life in a couple of years' time. If we find that, if it's there, or if the Mars Sample Return mission that we're talking about is being built, that will happen later this decade, if we find life, should we then send humans to go and perhaps interfere with Martian life? Many questions that you can debate that, and I think we've got to think about that and find out if there's life on Mars, and then maybe we'll send humans there. So there's lots of things to consider. The big things, there's still lots to do, and that's why we're looking at sending humans to the moon. First of all, back to the moon to learn how to live and work out in deep space on the moon, and we'll learn from that, and that will enable us one day perhaps to send humans to Mars.
Fantastic. Thank you very much. Yes, I think there's always ethical debates about everything that we do when we go off exploring. So I think that's a very important point to raise there. You started talking about going back to the moon. I've got a couple of questions that have come in just now. There's two of them that I'm going to throw in. So the first one is, my 9-year-old wants to know if any girls have also been into space. And then Lisa has asked, have any women been to the moon? Would either of you ladies like to pick that one up?
I will start off with the thing, I think, and then I'll hand over to Libby. Yes, girls have been into space. There are an awful lot of fantastic female astronauts, including one of my personal favourites and somewhat of a hero of mine, Samantha Cristoforetti. She is a European Space Agency astronaut, an Italian. But yeah, the gender balance of the astronaut corps, both the European Space Agency one and NASA's, is really starting to healthily shift in a more balanced direction, and it's much more common now to see female astronauts going up into space, which is brilliant to see and is something that's just going to continue. And as for women on the moon, they have not been yet. So far, all of the people that have set foot on the moon have been men. But Libby, I believe that there's some exciting news on the horizon regarding that.
Absolutely. There will be human missions back to the moon in the next few years. The NASA have the goal of landing people back on the moon by 2024, and their stated goal, their catchline, is it's going to be the next man and the first woman. So NASA are looking at doing that, and the future missions beyond that will be NASA, the European Space Agency, an international effort. We will see women on the moon. And you look back and you go, well, why haven't there been any back then? You look back at the time of the 60s and how astronauts were selected, and Sophie said that things are changing now. It's a reflection on what life was like back then, and I'm really looking forward to seeing the missions that will be going to the moon being a reflection on how life is now, and we will absolutely see a diverse crew go, as well we should, and women will be on the moon.
Brilliant. Very glad to hear it. I've been watching the Artemis program, and I've been watching various other things coming up. It's very exciting. Even the next Dragon crew mission, the diversity of the crew going up next is very exciting. So it's great to see. Right, so back to the questions that were asked in advance. We've got one here for Libby. What happens to the International Space Station when it is no longer suitable for human habitation? What comes next, and what will happen to the structure?
Oh, what a brilliant question. We're here talking today because we've got 20 years of continuous human presence on the space station, which is an amazing thing. And the first modules launched back in 1998. So parts of it are over 22 years old. But we're still looking at the space station being operational, continuing to do the great science and all the technology development that we get from it for at least the next 10 years or so. But one day, at the end of that, it is going to sadly have to come to an end, because we'll perhaps be replacing it with the next generation because it's old. We'll see. We'll keep it, I suspect, going as long as we can, because it's a great piece of technology. It's been a huge investment, and so we won't let it go lightly. But one day we will have to, and it won't get left in space. Because if it did, and it was uncontrolled, and it was just this giant piece of what we call space debris, junk floating around space, things would hit it, and that would cause more space debris. And we would end up polluting low Earth orbit, where the International Space Station is. And that orbit is home not just to the space station, but lots of satellites that provide data, provide services that we all use every day through our lives. So it's going to have to come down. And the thing to look at and think, well, how does that happen? You look at the last great space station, which was the Russian space station Mir. Was not as big as the space station, about a third the size of it, but it was a multi-modular space station. It was in orbit for about 20 years or so, not quite that long, and it came down in a single piece. You can't disintegrate it into different modules. It was a single piece. You basically attach a rocket to it, a rocket engine, to slow it down, bring it out of orbit, and you do that at just the right time. So as it re-enters the Earth's atmosphere, it starts to burn up through all the heat that it encounters as it slows down, slams into the Earth's atmosphere, just like the shooting stars you see. It's the same thing happening. You do it at just the right time, so it burns up and lands in the Pacific Ocean, a long, long way away from anywhere inhabited. So just in case anything survives that re-entry, as we expect some bits would, it will end up falling into the Pacific Ocean and landing at the bottom of the sea there. And that's what happened to Mir. Parts of it are down there in the bottom of the ocean swimming with the fish, I like to say. And sadly to me, because I've worked on the space station for many, many years now, that will be the fate of the International Space Station one day, but not yet. We've got years and years left of great science and great operations still to come.
I'm going to be buying a dinghy. I'm going looking for the parts. The National Space Centre will have them. We're quite happy. I don't like to think of it all on its own down there swimming with the fishes. That's the real reason. You mentioned space debris there. So Sophie, we have a couple of questions. Harry on Twitter says, how safe is the ISS? Is space debris a real danger? And then Eddie, who's age 3, would like to know, is space dangerous?
Yeah, two very important questions, I think. There's no doubt that if you're sending humans up into space, it is dangerous, both the environment of space itself and also probably more dangerous than that is the act of getting people from the surface of the Earth into space. The most risky time for an International Space Station astronaut is actually on launch or coming back on re-entry. But of course, there are a lot of hazards in space, and the astronauts are very much reliant on the systems of the space station itself to keep them alive. So with the vacuum of space being outside, you've always got to worry about keeping pressure up inside the space station, making sure that nothing is going to allow the oxygen and the gases inside to start to leak out. You've got to make sure that you are thinking about things like radiation protection for the astronauts. Now, in orbit, it's not such a huge consideration because the magnetic field of the Earth does a good job of shielding the astronauts from a lot of those cosmic rays, those high energy charged particles coming from the universe, the solar wind, and things like that. But it is still a consideration, and astronauts will be exposed to higher levels of radiation on the space station than they would be here on Earth. The other thing to remember is that a lot of what the astronauts do up there, as well as doing science, is maintenance on the space station itself. As Libby said, some sections of it are 22 years old already, so it's important that things get fixed, things get checked, that upgrades get installed, that new safety features get installed. And as a backup, in case something does go wrong on the station itself, you do have a Soyuz capsule that is docked, ready to act as an escape pod or as a lifeboat should something go wrong. But a big consideration is this idea of space debris. Space itself is populated by a huge number of bits of leftover missions, anything from the size of a grain of sand to, a half broken bit of satellite, and they're traveling very, very fast. I mean, even a bit of sand has about the same energy as a shotgun bullet if it were to hit something. So the station needs to be protected from that, and it's got a couple of ways that it can do that. It's got something called a Whipple shield, which protects the really important parts of the station, and that's designed to be able to absorb those impacts of these micrometeorites, these small bits of space debris, and stop them hitting any of the vital parts of the station. And should a larger bit of debris, which we're constantly tracking from here on Earth through a network of radar stations and observatories, should there be a larger danger from space debris, the station can, and has in the past, have a little bit of a boost. So they can fire a little engine at the back, which gives it a bit of a boost to its speed, lifts it a little bit higher in its orbit to avoid that. But that's always a last case scenario. So it is always going to be dangerous having people up in space, but the safety record of all of the space stations, not just the International Space Station, but the Chinese previous space station, Mir, that Libby talked about earlier, we have a phenomenal record of, even if there's been a fire on board, the procedures have been there in place to tackle that and to make sure that the astronauts are safe on board. So safety is always the first consideration.
Brilliant. Thank you very much, Sophie. If you want to know a bit more about space debris, head over to spacecentre.co.uk. I'm going to keep plugging it. And check out the tab that says news. There's a blog all about space debris because the European Space Agency have just done their report on the amount of space debris up there and the sort of things that are happening to combat that. So thank you very much for that one. Libby, I've got a question for you. Max Age 6 would like to know, what is the most frightening part of your job?
Hey Max, what a lovely question. What a great question. What is the most frightening part though? Today I work with all the scientists, with industry, making sure that the UK gets the best from all of our investments in the space station. And day to day, sort of it's just a desk job. A frightening thing, something perhaps that I worry about, is when there's something that the UK's invested in, that we've developed, just like the Astro Academy Principia hardware that Sophie was talking about right back at the beginning. When that goes on a rocket and it's going up, you go, well, what happens if it were to blow up? And that happened to some of the hardware that we were developing here in the UK for Tim's flight. And so it's not something that I get frightened about, because we think about what happens if. And in space, and particularly with astronauts and in operations, everybody working in mission control, which I used to work in too, we're always thinking about what if, and we train for these situations. Sophie was just talking about the dangers. The astronauts and all the people in mission control as well are always training and practicing what if there was a fire, what if something hit the space station and the air started rushing out. And so we practice these. And just like now, if a fire alarm goes off and we all know what to do, and we all know how to get to safety, and so that doesn't worry us quite as much. It's the same thing in space. So we don't get frightened because we practiced and we thought about it, and we know how to handle these challenges. And in the case of when the it was a SpaceX 7 cargo craft blew up, taking hardware with it, we had a plan, we had backups, we got that sorted, and made sure that the backups that we'd already got in place, the sort of spare sets, were there ready to go.
Brilliant. Thank you very much, Libby. There's loads of questions coming in, so I'm going to crack on and do this as quickly as I can. So we've got Stacey, aged 11, to both of you. Would you like to travel into space?
Yes.
Yes.
But I tell you an interesting bit to that question. Tim was selected as an astronaut back in 2008, Tim Peake. And when that application process happened with the astronauts, I was working in mission control, and lots of my friends said, do you want to apply? Do you want to be an astronaut? And back then, I didn't dream of being an astronaut. My dream was working in mission control. That's what I was doing. So I didn't apply. And now, 10 years later, and there's probably going to be another astronaut call from the European Space Agency coming out early next year, we think. I've said, I'd totally love to go to space. And I have been lucky enough to experience microgravity, to experience the floating. I've not been to space, but I've been on a plane that can fly in parabolas. It's actually just a sort of standard plane, an Airbus plane, just like the ones that we might get on to one, go on holiday or fly off to Europe or something. But four specially trained pilots can fly this in parabolas. And it's essentially doing to the plane the same thing that you would do if you kick a football, and it flies in an arc and it goes up and down. And the bit as you go over the top of that in the plane, everything is weightless, everything's floating, and you get to float just like the astronauts. And I've done that, and it was brilliant. I was helping science experiments. I wasn't just there to have fun, but as a byproduct, I got to experience microgravity, and it really was very, very lovely, and something I'd love to do again. And if I can go to space, even better.
And how about you, Sophie?
Yeah, absolutely. I think it's difficult to say that you wouldn't be wanting to go up into space if you work in the industry in any way, shape, or form. Whether it be an orbital flight just to be able to look back at the Earth and experience microgravity for an extended period of time, or whether it would be to go on a short duration trip to the moon, I would 100% be up for that. I will be honest, I'm not sure I would sign up for one of the much longer duration missions. I think 6 months on the ISS might be a little bit much for me, or even potentially a future Mars mission, but a short duration flight, absolutely 100%. And I do just want to point out as well that Libby was talking about going on one of these parabolic flights. The European Space Agency has an education program where they will allow students, I think master students at university and various other levels, to design experiments that they would like to trial in microgravity. And if you win the competition, you get to take your experiment on these flights and experience microgravity yourself. So if anybody is of that age or a student themselves, the project's called Fly My Thesis or Fly Your Thesis. Check it out. The European Space Agency is running that at the moment.
Yeah, I'm going to pick up on that. Sorry, Malika, just to say, because it's happening this week. So if you follow the feeds, you can see the teams. There's a team from the UK, from the University of Manchester, and I'm going to get it wrong. I think it's Edinburgh, but they're called Team Relox, and they have an experiment on a parabolic flight. They've probably done their second flight of the 3 today. It's just closed for this year, but you can get planning ready for next year. There's annual calls, and any UK teams that are selected, like Team Relox, can apply to the Space Agency as well. We support with a little bit of funding. So it is a great program, and ESA have a lot of education programs to help students. Not just on parabolic flights, there are ones with drop towers and centrifuges, and loads and loads of opportunities. And I really encourage anyone who's out there thinking about, should I apply? No, I'll never get in. Give it a go. Back when I was a student, I got the European Space Agency sponsored me to go off to a big space conference, which I got just for applying. So absolutely go and make the most of those opportunities.
Yeah, no, absolutely. There's lots of educational product out there, right from tiny children. So Paxi and the sort of the European Space Agency's mascot will do basic science learning. So if you've got small children, check out the European Space Agency's kids channel, and then it goes all the way up to various high schools and university levels. So there's loads of stuff out there, resources. We'll try and stick some links in this conversation at the end so that you can see what's out there. While we're talking about this subject, we've just got a question coming in. So Soph, can you pick up on this one? I'm 10 years old. I'm wondering where and how is the best place to start to be an astronaut?
Oh, great question. And asking that question is the best place to start, because first thing, important thing to remember is it's not a career that you do from the very beginning. So you don't go off and train to be an astronaut straight out of school or straight out of university. Astronauts are people that have careers beforehand. They might be in the military, so they might be a test pilot, they might be a scientist, a doctor, an engineer, a computer programmer. But all these people have something in common, and that is that they have got a very high skill set in often things like mathematics and science, so the STEM subjects, engineering, etc. But they all have careers first, and they will have a career that they enjoy, that they're dedicated to, and that they really work hard at and shine in. So the first bit of advice is to make sure that you look at, other than being an astronaut, what is the career you would like? Would you like to be an astronomer? Would you like to be an engineer, a pilot? Would you like to, work in industry building things? And focus on that. And the other important thing that seems to be very common among all of the astronauts that I've met is taking opportunities and looking for opportunities. So, if somebody says, hey, do you want to have a go at this? Do you want to join this program? Do you want to enter this competition? Go, yes, what is it? Tell me about it. Because the more that you do and the more that you try and the more that you learn, the more likely you are to find the thing that you want to do. And then once you've done that for a while, and the call out goes out from the European Space Agency for astronauts again, They will be looking for people with a degree in a STEM subject and with an established career and a really good set of skills, communication, team working skills, fairly good physical skills. So do lots of things, try lots of things, and be involved in as many things as you can to really round out that skill set.
Brilliant. Thank you very much, Sophie. You've answered quite a lot of the questions that we had in advance through other questions that you've answered. So I'm going to start picking some up from the comments, I think. But I think they're all things that you can pretty much handle. So we'll start off with a nice, easy one to both of you. So Isla, age 6, would like to know, what's the most exciting thing you're working on right now?
Oh, I'll take that one while Sophie thinks. For me, it's some experiments that are coming to the space station soon. One of them, there's loads to pick, but I'm going to pick one out because it really excites me. It's a team in Liverpool who are looking at how muscles change. Now, this is a team in Liverpool who are really, really good at understanding muscles. The University of Science, they're Professor Malcolm Jackson. I'll give him a shout out. No relation, I should add. But they are a group that look at how bodies change and muscles change in particular as we get old, because we're all going to get old one day, hopefully. And our muscles, we know we get weaker. We will know people in our lives who suffer because they're getting older and they're getting weaker and they find it harder to move around. And we don't understand what happens always to these muscles and what the changes are. And the group's been looking at that. And they've realized that they do all sorts of other science, but they've realized that going into space and looking at how muscles change in space can help them answer those questions. And so we're developing an experiment. They're developing an experiment. The UK Space Agency is funding it to take some teeny tiny little bits of muscle construct that they grow themselves in labs from some cells into space, and then they're going to put an electric signal through them to make them contract, just like our muscles contract on Earth when we send electrical signals from our brain to say, right, I want to move my hand. That's an electrical signal telling your muscles to contract. They're going to do that in space, and it's going to help them learn about muscles. And that's, for me, a great example of why we do research in space in the International Space Station, because it's just a question that's there in their research generally, and space is going to be the way that they can learn more about it. And then in doing that, help all of us, because if we understand how our muscles change, we might be able to give better advice for exercise or medication for older people, and we'll just learn much more about how our bodies work every day.
Brilliant. Yeah, I've just started doing couch to 5K, so I'd really like to know how to make my muscles not quite so painful. So, Sophie, how about you? What's the most exciting thing you're working on?
So in terms of project-wise, the most exciting and most challenging thing at the moment is we're developing a set of online masterclasses. So taking the activities that we would do at the National Space Centre in our lab at the Space Centre, and turning them into an online format that we can share with schools, so that during the current times, you don't just have to be able to come to us to be able to learn about some really exciting space science. So we're developing one looking at Mars sample returns, so looking at analysing Mars analog samples and looking at the chemistry of Martian rock. We're looking at the physics of how rockets work and the spaceports that are in development here in the UK right now. And then the corny answer, and this is true though, I mean, it's corny, but it's absolutely true. The most exciting thing I'm always working on is our space engineering course, because genuinely the students on this course, some of them go on to achieve phenomenal things, to go off and work in the aerospace and eventually, hopefully, the space industries as well. And watching them learn and gain confidence and learn new skills and really embrace being a scientist and engineer, that is always really exciting.
Oh, thank you, Sophie. I love that answer. That's fantastic. Right, so one for you here, Libby. So Holly, age 6, wants to know, if something needs fixing on the space station, who fixes it and where do they get the spare parts from? And I think we should mention the toilet, definitely.
Holly, that's a lovely question. There are no space plumbers that you can call out. There's no one you can suddenly get on a a rocket to come and fix something. The answer is if something needs physically fixing, you get in there with a screwdriver or plumbing, it's the astronauts themselves who do it. So they are trained in so many different things. It's one of the reasons it takes years to get ready for a flight into space, because you've got to learn how to fix the water pumps, how to fix the air conditioning, how to fix all the different science experiments in case they go wrong, and how to fix the toilet. There are 2 toilets on the International Space Station. One at the Russian segment end. I should say the space station is sort of 2 halves. There's a part that Russia built, and there's a part that the United States and Europe and Japan and Canada built. They're sort of stuck together. And it's essentially a toilet, one at each end. But if the toilet breaks, basically all work stops until the toilet is fixed, because it's the most important thing. If that's broken and you have floating wee and poo, it's not fun at all. But they do that. The astronauts do all that fixing with the help of the team of people in mission control. So all around the world, 24 hours a day, 7 days a week, 365 days a year, there are people in mission control helping the astronauts, looking at all those different systems. And they are experts, and there's a team of people, and you've got different people who are experts in different systems. So when I worked in mission control, I knew all about the computers and the communication systems in the Columbus module, which is European Space Agency's part of the space station. And if something were to go wrong with the computer, the crew could call down to mission control. If I was on shift that day, the flight director would look at me and I'd have to answer the question and explain what was wrong with the computer. And if mission control can fix it, because they can send what we call commands, they can send instructions to the space station remotely, they will. But if you've got to get in there with a hammer or a spanner, you've got the crew to do it. And you asked about what tools do they have. So on the space station, they have a huge tool set, lots of different things. We've tried to think of every possible different eventuality and make sure that we've got the tools to fix everything. But sometimes we don't think of everything. And there's a great story that happened a few years ago on a spacewalk. There was a box that needed to be fixed. It was called a main bus switching unit, an MBSU, part of the chain that gets the electricity from the solar arrays, collect all the sun's rays, turn it into electricity, distributes that power all over the space station. It was part of that, and it needed fixing. Long story, but essentially the astronauts went out to take the old box out and put a new one in, and the new box, they couldn't screw the bolts in, and they've in the end worked out why, but they needed to clean out some metal shavings. They didn't have a tool. They used a toothbrush. In the end, the mission controllers thought, what can we do with that? We need a toothbrush. They put a toothbrush on the end of a spacewalk tool. They used it to clean out the bolt parts, and it worked. And still today, in the arsenal of spacewalking tools, they use a toothbrush, because after that, the engineers thought, okay, we need a tool in case this ever goes wrong again. And they worked out it was going to cost far too much money, and the toothbrush was just perfect. So there's lots and lots of different tools, including a toothbrush. And then he said, but what happens if we were to go and send humans to the moon, one day onto Mars? Can we take everything with us? And we really can't. The more we take with us, the more rockets we need, the harder it gets, because it's all about mass. And so the advent that we're seeing here on Earth, we're also seeing up in space, where we're looking at 3D printing. What can we build? And there's a plastic 3D printer on the space station, which has been used to build a spanner. The astronaut said, I need a tool for this. Mission control worked out what it was. They sent the instructions up to the printer printed the tool, and that's what they had. And we're looking at that sort of technology to make sure that when we go one day back to the moon or onto Mars, we can have all the tools we need, because we'll just be able to create them when we need them.
Brilliant, thank you very much. Yes, I was particularly excited about the 3D printer that made pizza. So I like that idea. So Sophie, I've got a question here that's just come in that might actually link quite nicely to the idea of that 3D printer, because it's not just a 3D printer, because it's having to operate in microgravity, which obviously is a challenge that they have on the space station. So we've got a question that's come in here. So Daniel would like to know, why is there no gravity in space?
That is a really important question, because it's a question we get asked all the time. And the first thing to state is that there is gravity in space. So if I've got an object like the Earth, I'm going to bring my inflatable Earth here. The Earth is made of a load of mass, stuff, material. And gravity is produced by anything that has mass. I'm producing gravity, my house is producing gravity, my cup is producing a little bit of gravity around it. But the more mass something has, the greater and the stronger the gravity around it will be. So something as big as the Earth is going to exert a huge gravitational pull on anything both on the surface and above it in orbit, like the International Space Station. Now, the key thing is that the International Space Station isn't just sat there above the top of the surface of the Earth. If I were to just plonk the space station there and let go of it, then the gravity of the Earth is going to pull it down. And if you imagine being on a theme park ride, one of those drop towers that drops you down suddenly under gravity, and let's say you were to take something like a watermelon with you onto that ride and release it at the instant that you start to drop, well, gravity is going to pull all of your mass and all of the mass of that watermelon down with the same acceleration, the same change of speed. So for 2 seconds or so, as you're free falling, you and the watermelon would fall at the same rate. So the watermelon would look like it's floating in front of you until you stop and the watermelon continues downwards and hits the floor. And the same thing is happening with the space station. If the space station were just dropping and falling like a giant elevator or a giant lift, then all the time that it was falling towards the Earth, anything inside of it would also be falling and so would be floating inside. We call this free fall. Now, the key thing with the International Space Station is that it's not just sat there, it's in orbit around the Earth. So it's got enough sideways speed that instead of going off in a straight line, gravity is pulling it back just enough that it will go in a curved path and orbit around the Earth. But it's still being pulled down by the gravity of the Earth. In fact, the gravity of the Earth is about 91% as strong on the space station as it is on the surface. So the key is they're in free fall, but they're falling around the Earth. And that's why it seems there's no gravity on the space station.
Brilliant, and you got to use your prop, so we're happy. Thanks, Sophie. Right, Libby, this one's for you. I've got 2 questions, and it's your own fault because you got the level, okay? So these ones relate to wee and poo. So Marie would like to know what happens to waste on the space station, so waste in general. And Abby, age 11, wants to know, in a book I'm reading, the boy lives on the space station and they have to drink their own wee, purified, because they don't have enough water. Do astronauts on the ISS have the same problem? Oh, you're muted.
I'm back. Hello. I say, what a great question. It's not a problem on the space station. That's what they do, and that's what we want them to do. It comes back to that question of waste. And I was saying a little bit earlier that when we get something into space, we've got to put it on top of a rocket. And so mass, how much stuff are you going to get into space, is one of the really critical questions, because the more stuff you have to take into space, the bigger rocket you need, or the more often you need to send rockets. And so we try and recycle as much as possible as we can on the International Space Station. The air is recycled. The astronauts inhale oxygen, breathe out carbon dioxide, just like we do on Earth. And that carbon dioxide gets collected up in systems on the space station, the particles, the atoms inside the molecules get rearranged. So rather than carbon joined with oxygen, you split it back up through some great chemistry, and you wind up with oxygen that you can breathe again. So the air gets recycled and we can breathe more oxygen. The same happens to water. And so this problem of water and that you have in your book, so it's not a problem. Everything, all the air conditioning water, all the condensate that gets collected from these air conditioning systems, all the wee from the toilet gets collected and it all gets purified and turned back into drinking water. And all of these recycling systems that we're working out on the space station to keep the crew alive and to minimize how much stuff we need to bring up from Earth feeds back in and trickles down into systems that we use here on Earth. And the water recycling technology that we've developed for the space station is helping and has been turned into technology that is helping people in developing countries who don't have access to clean water. or lots of water, lots of clean water, find themselves with systems that they can use to have much more clean drinking water. And so that's one of the great things that the research and the technology on the space station does. The rest of the rubbish, though, and there's a lot of things where we haven't worked out recycling, and one of those things is things like clothes. People go, how do you do washing in space? What about all your clothes? You can't wash clothes in space. We haven't got a space washing machine. And so the answer is you just wear them a lot until they're so smelly and so dirty that they get thrown away. And that's one of the say that there are places where we can still do a lot more with recycling, but we make the astronauts really, really wear their clothes out. One pair of pants has to last about a week, and their exercise gear has to last, I think, at least about a month, and they're exercising for 2 hours every single day. So stuff can get really, really smelly before they get thrown away. But when we do throw things away and we gather it all up and all that rubbish, it gets packed back into the cargo spacecraft that brought it up in the first place. And so you sort of basically, when the cargo spaceship arrives, all the fresh supplies get unpacked, all the rubbish gets put back in. That cargo spacecraft then leaves the space station and re-enters the Earth's atmosphere. And if you were tuned in earlier, I was talking about what happened to the Mir space station when it re-entered. If you haven't got a heat shield, if the spacecraft isn't protected from the blistering heat that gets generated when something enters the Earth's atmosphere, re-enters the Earth's atmosphere in this case, it will burn up. That's why what we see in the sky, we see a shooting star, that's a bit of space rock that's burning up in the atmosphere. And the same thing happens to that cargo spacecraft. So all the rubbish gets turned into a giant shooting star. And again, if you're looking in the right place at the right time and you see a big streak across the sky, probably over the Pacific Ocean again, I'm afraid you've got to go out in your dinghy there again, Malika. That's what's happening to all the rubbish. It's all burning up in the atmosphere.
Well, at least I'm making good use of my dinghy, so that's great. Yes, Toby, age 5, wanted to know how astronauts wash their clothes, so I think you've answered that question. And I think you've also made us realise that it's not all glamour being an astronaut, is it? And also, I read that when citrus fruit comes up on the restock, it's the smell is so nice and refreshing, and you can work out why now if they have to wear pants for a week. So thank you for that one. So let's talk about those astronauts. So Yusuf, age 4, what kind of projects do astronauts work on? So what sort of things are they doing up there?
Shall I take that one?
Yeah, go on, Libby.
Yeah. So there are over 250 experiments, usually around 250 experiments happening at any one time. So that's a lot of science that's happening on the International Space Station. The astronauts work Monday to Friday, a little bit of Saturday. They don't work all the time. We let them sleep. We let them have time off in the evenings to relax. If you were, just like we all are at the minute, chained, stuck in your place of work all the time, I'm here working from home, a lot of other people are, you'd go stir crazy if you could only work or sleep. And so the astronauts have a normal working day. So in that time, they're working on all these experiments. A lot of them are actually being run by the scientists on Earth. And a lot of what the crew do is putting in new experiments in place, sort of plugging them into the data systems, the communication systems, and then leaving the experiments to run with the help and the oversight of the scientists back on Earth. But a lot, the science experiments that they get really involved with are the ones that are on them. We really want to understand how the human body changes in space. I was talking a little bit earlier about how muscles change and how we've got scientists looking at that. And the astronauts are guinea pigs. They are human guinea pigs, I sometimes call them. They are prodded and poked, and we take samples from them. We take muscle biopsies. They have to take blood and saliva, all sorts of different samples for scientists to track how their bodies are changing. Because when astronauts go into space, they essentially get old really quickly. A lot of the things we see happen to humans on Earth as we get old, our bones get weaker, our muscles get weaker, our skin gets thinner, our eyesight changes. We see these same changes happen in space over a short period of time to people who are otherwise young and healthy. So we can learn all sorts of things by studying the astronauts. So that's sort of most of their day is doing science experiments. They also have to do maintenance. They have to do 2 hours of exercise every day to keep their bones and their muscles as strong as possible, so that when they come back to Earth, particularly if they had to come back to Earth in an emergency, they can come back safely and they could get out of their spacecraft, and they could look after themselves if they had to land and there was no one around to help them. That's one of the reasons that they exercise so much. They do cleaning every Saturday morning, just like we have to clean our houses. They have to clean the space station. They do some interviews. They like talking to people. They like talking to school children, sharing the stories, making sure that everybody understands what's happening on the space station. And then they usually get Sundays off. And on their days off, they watch movies. They ring their friends and family. They can ring anyone on Earth at any point. They have a sort of the ability to phone any phone on Earth all the time. But one of the things they really enjoy doing is looking out the window, taking photographs and looking back down on Earth and out into the universe and the solar system and seeing what's out there. So yeah, looking out the window is something the astronauts love to do in their spare time.
Or if you're Tim Peake, run a marathon, because, why not? You're in space, you might as well. An amazing man. Right, we have come to the end of our session. I've got one more question for you, but we've come to the end of our hour. But I think I'd like to go out with this one. So Tim, aged 5, would like to know, he says, I'm named after Tim Peake, and he's my hero. Who is your hero? Sophie, do you want to pick that one up first?
Oh, blimey. It's really, really difficult. In truth, I have lots and lots of heroes. It kind of depends. I have politics heroes, musician heroes, art heroes, and things like that. The hero that I'm thinking about a lot at the moment is a scientist called Carl Sagan. Carl Sagan was a space scientist and astrophysicist, and he was the principal investigator on a phenomenal mission called the Voyager mission. So in the 1970s, 2 spacecraft, Voyager 1 and Voyager 2, embarked on this massive journey around our solar system. It was literally a once-in-a-lifetime opportunity. It was going to be a huge amount of time before the planets were aligned so favorably again. And Carl Sagan was not only a brilliant scientist, but he was a brilliant communicator of that science. He was one of the first people that was really popular and popularized the talking about science in a way that other people can understand. So I remember growing up watching a show that he made called Cosmos, which was him just talking about the universe, but in terms that anybody could understand. And he had a brilliant way with words and fabulous turtleneck sweaters. So yeah, he from a science communication standpoint, being that talking about science is my job, he's definitely up there on my list of heroes.
Well done. You share a hero with Bill Nye, the science guy, because he said Carl Sagan too. And how about you, Libby?
For me, so there are so many different people across all sorts of different things. But where I come back to is what it was that got me excited about space in the first place. And for me, it was the stories of the people in mission control through the early spacecraft missions, through Apollo, through Gemini, Mercury. They were the programs that led to Apollo and the moon landings. And if you've seen the film Apollo 13, you'll know that the person sitting in the hot seat in the flight director chair during the Apollo 13 challenges, problems, emergency, accident, and also actually when Apollo 11 landed on the moon was someone called Gene Kranz. And he was a flight director who worked in mission control right from the early days, and he set out the principles of how mission control should work. Was really one of the founding people of the concept of mission control and how all that works. And he's someone who I love reading about, and the things that he and his team did in those early days, and certainly that was what led me to get excited about space and working in mission control. So that was one person who learning about has sort of opened my eyes to what I could do. But there are people all across the industry in all sorts of different walks of life from all sorts of different eras, and I think one of the things that often sticks with all of them is that they do things that they enjoy, and they do them. They don't listen to people when people say, "Oh, you can't do that, you shouldn't do that." And I think that's so important in life, that people should do the things they enjoy.
No, absolutely, and we were really lucky to have some fantastic mission controllers come over to the National Space Centre, including Jerry Griffin and Bill Moon, Cy Begot, Manfred von Dutch, and they all would agree with you. And absolutely, Gene Kranz's name is spoken with a lot of respect. So well done for that one. That's brilliant. I have to say thank you very much for your time. Thank you very much for joining us. Some brilliant answers. We haven't answered all the questions. There's never enough time. But Sophie and I will be back, and we'll be back next Friday. And Sophie, we're joined by Charles Cockle from the University of Edinburgh, and we're going to talk about astrobiology. So for people that don't know what astrobiology is, can you give us a really quick summary?
Super quick summary. It is effectively professional alien hunting. It is trying to figure out what kind of life forms could exist elsewhere in our solar system, and then figuring out what experiments we need to do to send there to find them.
Brilliant, that was fantastic, thank you. So if you'd like to know more about extremophiles, tardigrades, aliens and all the like, do come and join us next Friday and get your questions in early and we'll see what we can do. Other than that, thank you very much, ladies. That's been brilliant. Loads of questions we couldn't get round to. Isla age 6, you'd like to know more about what they're able to grow in space. Friday on our Facebook channel, there'll be a brand new video talking about exactly that. And there's even a recipe that you can follow. So do come and join us. We've got loads of exciting things coming up over the next 4 weeks. We will make sure that we put out lots of these sessions and lots of things to help you get through the next 4 weeks. But other than that, stay safe, and a huge thanks for joining us this evening and supporting the National Space Centre. Good night.